Autonomous AI agents are becoming increasingly capable. They can call APIs, use tools, interact with external systems, and perform complex multi-step tasks. But there is a problem. How do we actually know that an agent is reliable? Traditional testing usually means writing a few prompts and checking whether the expected answer was produced or not. But real agent failures aren't always that simple. An agent might enter a tool call loop, perform an unsafe destructive action, drift away from its original goal, or become less reliable after an update. Relib was built to address exactly this problem. Relib is an AI agent evaluation and reliability engine. Think of it as a CI/CD reliability layer for autonomous AI agents. Instead of simply testing whether an agent can complete a task, Relib generates adversarial scenarios, executes the agent in a controlled environment, captures what actually happened, analyzes its behavior, and tracks reliability across versions. Let's look at the architecture for a couple minutes. This architecture is designed around independent services and event-driven communication. The process starts with the scenario generator. It takes an agent's prompt, tool definitions, and task domain and generates adversarial evaluation scenarios. These scenarios are stored persistently and pushed and published to Kafka through the scenario jobs topic. The agent runner consumes these jobs and starts a temporal workflow. Temporal handles the durable orchestration of the evaluation, including workflow state, retries, and timeouts. The actual agent execution happens inside a controlled sandbox with mock tools, so potentially destructive operations don't touch real infrastructure. During execution, the trace capturer records tool calls, arguments, results, latency, and execution state into the trace store. Once the run is complete, the analyzer queries these stored traces and evaluates agent's behavior. One architectural detail we are particularly happy with is the secondary Kafka boundary. The analyzer publishes a structured reliability event to the analysis events topic. The scorecard service and regression tracker then consume that event independently. So these aren't sequential services. The scorecard maintains the current reliability picture while the regression tracker maintains historical results across agent versions. That means each downstream component can scale and evolve independently. Let's look at the prototype. And this is the developer facing dashboard for the system. Here we can see the current reliability score, evaluation count, failure rate, and critical failures. We can trigger an evaluation and see the resulting runs. For an individual execution, we can inspect the actual execution trace. For example, we can see the agent checking deployment status and then attempting a destructive operation. The scorecard gives us the point in time reliability metrics. And the regression tracker lets us compare different agent versions and identify changes in reliability. The most important part of Relib isn't the AI model, it's the infrastructure around the agent. Scenario generation is decoupled from execution through Kafka. Temporal handles durable agent evaluation workflows. Execution traces are persisted independently from analysis, and the analysis results are distributed through another event stream to independent consumers. This makes the system much easier to scale and extend them than a single pipeline where every component is tightly coupled. This is currently a hackathon prototype, but the bigger direction is to turn Relib into a reusable reliability layer for autonomous agents. One area we are particularly interested in is integrating it directly with coding agents such as Cloud Code and Cursor. A coding agent could make a change, Relib could automatically generate adversarial evaluations, execute them in isolation, analyze the resulting behavior, and determine whether a change introduced a reliability regression or not. Eventually, this could become a reusable developer package or CI/CD reliability gate for autonomous systems. Autonomous agents should not only be tested for whether they can succeed, they should continuously be tested for how they fail. That's what Relib is built to do. Thank you.